Unit vector. What is meant by unit vector? Unit vector means a vector whose magnitude is 1, but theta is 90, cos 90 is 0. Like that we can rearrange. To derive this in 3D, the first basic is you should be able to draw the diagram and x2 plus y1 y2 plus z1 z2. So if two vectors are perpendicular, then the dot product is 0 is one of the basic. How to do dot product of any two vectors? Multiply the quotients and add. What is the quotient here? A. What is the Cartesian equation of plane? A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0 is the Cartesian equation of plane. Welcome to the session, dear students. Today we'll go ahead with important concept, that is 3-dimensional geometry, and we'll study planes in 3D. So now plane, to understand plane, very first concept of vector we should be thorough with. All of you know, if two vectors are perpendicular, suppose vector A and vector B, how these two are? They are perpendicular. If two vectors are perpendicular, if two vectors, say here vector A and vector B are perpendicular, if suppose they are perpendicular, what is the condition? If they are perpendicular, then what is the rule? If two vectors are perpendicular, then their dot product is 0. So then their dot product is what? 0, because angle between them, cos theta, theta basically 90, cos theta is A dot B by magnitude A, magnitude B, but theta is 90, cos 90 is 0. Like that we can rearrange. We have proved this in vectors. So remember this. So this will become a basic for us to derive planes. If two vectors are perpendicular, then their dot product is 0. If vector A and vector B are perpendicular, then vector A dot vector B is 0. Suppose vector P and vector Q are perpendicular, then P dot Q is what? 0. What is the condition? If two vectors are perpendicular, then their dot product is 0. Very, very important. And second important thing is, you should know how to find dot product. If I give vector A is equal to x1 I cap plus y1 j cap plus z1 k cap, and I'll give vector B is equal to x2 I cap plus y2 j cap plus z2 k cap. All of you know how to find dot product. Then vector A dot vector B. How to find vector A dot vector B? Multiply the quotients x1 x2 plus y1 y2 plus z1 z2. Dot product is what? x1 x2 plus y1 y2 plus z1 z2. So if two vectors are perpendicular, then the dot product is 0 is one of the basic. Second one is how to find dot product. And you know, any vector can be written in terms of position vector using law of triangle vectors. If any vector can be written in terms of position vectors, can be written in terms of what? Position vectors. You can write it in terms of what? PVs, in terms of position vector. This is also one of the important basic what you studied. Meaning vector AB can be written as vector OB minus OA. This is from law of triangle of vectors. So if I take 3 dimensions, x-axis, y-axis, z-axis, and this is origin O to A and O to B, position vector, and I'll draw the triangle. This is OA, this is OB, and you can say AB. So using law of triangle of vector, you can say vector OA plus vector AB becomes vector OB. Means O to A to B gives you OB. Or rearrange this, AB becomes OB minus OA. Do we have so much of time to rearrange and do all these things? This is a basic, and we no need to use this always. Directly you can take any vector can be written in terms of position vector. Terminal position vector minus initial position vector. AB can be written as OB minus OA. Mean second point position vector. What is second point? B. Its position vector is OB minus first point position vector. What is the first point? A, OA. Suppose if I give PQ, PQ can be written as OQ minus OP. OQ minus OP. Terminal position vector minus initial position vector. Similarly, RS, if I give vector RS, you can write it as what? Vector OS minus vector OR. Any vector can be written in terms of position vector, that is terminal position vector minus initial position vector. These are the two basics required to derive planes. Now, what is the first case? if two vectors, if vector A and vector B are what? Perpendicular, then what is the condition? Then dot product is 0. So first basic. What is the second condition? The second condition is how to find any vector in terms of position vector. AB vector AB can be written in terms of OB minus OA. Terminal position minus initial position vector. Or if I give PQ, PQ can also be written in terms of OQ minus OP. Like that you can write any vector in terms of position vectors. These are the two basics which you should become thorough. Now going ahead, we'll discuss planes. To discuss the planes, these two vector basics you need to know. Now plane. So equation of plane. So you know a plane, suppose if I take a plane, for this plane so many parameters. For this plane I can draw a perpendicular to this plane. Perpendicular to the plane means what? Normal to the plane. Or I can consider a point in the plane. Like that, so many parameters. Point in the plane is a parameter. Perpendicular to the plane is a parameter. Collinear points, non-collinear points are parameters. So using parameters like what? Perpendicular vector, or we can also use what is called as normal. Normal is also what? Perpendicular. Or we can also use point in the plane, and we can use three non-collinear points. We can also use what? Three non-collinear points. Using this as parameters, we can create vector. We can create plane. So plane also, for any plane, I can draw a perpendicular. We call it as normal to the plane. So taking this basics, first form will derive. So in plane, normal form of plane. I'm going to derive what? Normal form of plane. So derive equation of plane in normal form. They'll ask like this. Derive, this is a standard question. Derive equation of plane. They want you to derive what? Equation of plane. Plane in normal form. In normal form. This is a repeated question in your board exam. Normal form. And for any form, we'll have vector form as well as Cartesian form. So for this also we'll discuss. To derive this in 3D, the first basic is you should be able to draw the diagram and consider considerations. Now we'll take, this is 3 dimensions, 3-dimensional geometry. I'll take 3 dimensions. What are the 3 dimensions? X-axis, Y-axis and Z-axis. So this is X-axis, Y-axis, Z-axis, mutually perpendicular line, and this point is point of intersection, we say origin. Now let me consider a plane. So now I'll take what is required, that is plane. So this is plane. So this is the plane I'm taking. And we'll take normal to the plane drawn from origin. So now for this plane, let us draw normal. Let us consider normal to the plane. What is meant by normal? Perpendicular. So this is normal to the plane. So for any normal that is perpendicular, we consider before this simple. So this is normal, or we'll take one arbitrary point to make it simple. Let me take an arbitrary point in the plane. So I'll take PB any point in the plane. PB any point in the plane. ON be the normal to the plane. And we'll take an extra construction, that is for any derivation we should take one arbitrary point. Let us consider, let P be arbitrary point in the plane. So I'll join NP, a vector, and this is perpendicular. Normal means what? Perpendicular drawn from origin to the plane. So here in 3D it is difficult to show the plane. See, this is a plane and this is the normal to the plane drawn from origin. So here this is the plane and ON is the normal and PB any point in the plane. You can see ON and NP, they are perpendicular. So now these two are perpendicular. So first we have to do considerations. What are the considerations? We have to take a plane. We have taken a plane. Let ON be the normal to the plane, P be a point in the plane, and you can see ON and NP, and we should assume ON is one vector and NP is another vector, and these two vectors are perpendicular. So first we should write considerations to derive. What are the considerations? Consider a plane. We have taken a plane. Consider a plane. Vector ON is normal to the plane. Normal means what? Perpendicular. Normal to the plane from origin. To the plane from origin. So dear students, we will assume the ON value. Vector ON is D into n cap. D is the length or magnitude of ON. N cap is the direction. N cap is the unit vector along normal. So this length is D and n cap. So now what is n cap? Where we say n cap is the unit vector along the normal. Is the unit vector along the normal. So dear students, here I have taken a plane, and for that plane I have drawn a normal ON, and that ON is perpendicular to the plane drawn from origin. ON length is D and direction is n cap. For a vector, you know it will have magnitude as well as direction. N cap is a unit vector in the direction of ON. So ON value is D into n cap. And we have, so we will take another point. Consider a point. Consider a point P in plane. Join what? NP. We have joined N to P. So here you can see two vectors. One is ON, the other one is NP. From the figure, ON and NP are what? Perpendicular. From the figure, it is clear. So now ON and NP both are perpendicular. So we say from the figure, vector ON is perpendicular to NP. All of you know, if any two vectors are perpendicular, then their dot product is 0. That is what I started today. If any two vectors are perpendicular, then their dot product is 0. So therefore, ON and NP are perpendicular. I can say their dot product. NP dot ON is 0. Can I take this? Why I can consider this? Because they are perpendicular. See the diagram. ON and NP, they are perpendicular. They are at 90 degrees. If any two vectors are perpendicular, then their dot product is 0. So ON and NP are perpendicular. So NP dot ON is 0. And you know any vector can be written as position in terms of position vector. NP can be written as OP minus ON. OP minus ON. Dot we have ON is equal to what? 0. Now substitute the value. See, let us assume in the beginning we should assume. So let P be a point and join NP, and vector OP, position vector of P, will assume it as vector R. So in the diagram O to P, so we will take a position vector of OP. If I draw this vector, so draw a vector. What is OP? OP means position vector of P. So all of you know, O to P will assume, let us assume vector OP is position vector of point P. Always in all the derivations of 3D, OP will assume it as R. OP, P is an arbitrary point. Let P be a point in the plane, and OP means position vector of P. What is meant by position vector? Vector drawn from origin to the given point. From origin to P, I have drawn a vector OP, and vector OP is R. So now I'll substitute it. In the place of OP, vector R minus, in the place of ON, what is ON? D n cap. ON is D n cap into, again dot D n cap is equal to 0. Now dear student, D is a number. Number if it goes that side. Number if you transfer that side. R minus D n cap dot, we have n cap is equal to 0 by D. This into D, transfer that side, divide by D on both sides. So 0 by D is what? 0. Dot, D dot n cap is equal to 0. Now multiply R dot n cap minus D dot n cap is n cap the whole square is equal to 0. R dot n cap minus, you know, A dot A. So in vectors we learned vector A dot vector A is magnitude A square. Like that n dot n magnitude n square can be written as n dot n. So this will be n dot n can be written as magnitude n square. Here, see here, if I do term wise, n dot n, you know, n dot n is what? Magnitude n square. Magnitude n, I told you, n cap is what? Unit vector. What is meant by unit vector? Unit vector means a vector whose magnitude is 1. So n is unit vector, so it is 1. So r dot n cap minus d into 1 equal to 0, or simply r dot n cap is minus d, r dot n cap minus d1 z d equal to 0, minus d transfer outside, r dot n cap is equal to d. This is the normal form of plane. What is normal form of plane? R dot n cap is equal to d. Let me summarize. So we have taken a plane and ON be the normal to the plane, P be any point in the plane. Then draw OP position vector and ON normal. You can see from the figure ON and NP are perpendicular. ON and NP are perpendicular. You know very well, if any two vectors are perpendicular, then their dot product is 0. So NP dot ON becomes 0. NP can be written as OP minus ON dot ON equal to 0. And OP means position vector of P. In all the derivations, OP we assume it as R. Vector R minus vector ON we took it as D n cap. So ON is equal to what? D into n cap, substitute it. And outside also we have ON, that is D into n cap. Now multiply R dot D n cap, R dot D n cap. Here D is there, D is a number, transfer this side, it becomes 0 divided by 0 by D is 0. So now R dot n cap minus D n cap dot n cap. N cap dot n cap is magnitude n cap square. Magnitude n is 1 because n cap is unit vector. Unit vector means whose magnitude is 1. So it will become D into 1. 1 square is 1. So it will become R dot n cap minus D equal to 0, or R dot n cap equal to what? D. So now this is called as normal form of plane. For same normal form, we will take Cartesian form. So normal form, vector form, by vector form, just now we got, by vector form, we have R dot n cap is equal to D. Now let n cap is equal to Li cap plus mj cap, Li cap, mj cap plus nk cap, n cap. This is vector n. So now vector R is position vector of P. So if I assume point P, always will take point P as x, y, z. Position vector of P is OP. OP is R, and R is what? Xi cap plus yj cap plus zk cap. If point is xyz, in vectors chapter I taught you, if point is xyz, if you associate ijk, I cap, j cap, k cap, it will become position vector. P is xyz. Position vector of P is OP. OP in this derivation is vector R. Vector R is xi cap plus yj cap plus zk cap. Coming to this, now you know this n cap and we took this. So by vector form, you know what is the vector form? By vector form, plane equation is R dot n cap is equal to D. So now you do dot product. So what is dot product of two vector? Multiply the quotients and add L into x plus m into y plus n into z. So it will become Lx plus my plus nz is equal to what? D. This is the Cartesian form. I have done Cartesian. What is that? Dot product. What is dot product? Quotients of I should multiply L into x plus m into y plus n into z. So this is the Cartesian form. Is the Cartesian form. The Cartesian form. Very important. And here Lxm, L, M, N are direction cosines of normal to the plane. They are not direction ratios. They are what? Direction cosines. Because n cap means unit vector. Unit means you should divide by magnitude. When you divide by magnitude, it will become direction cosines of what? Normal. So now I have derived normal form of plane. Very easy if you know the diagram. What is the diagram? So a draft diagram is, we'll take 3D. So 3 dimensions we'll take. And along with that, what we'll do? Origin we'll take one normal ON, and we'll take a point in the plane, and there is a plane like this, and we'll join this, and these two ON and NP are perpendicular is the basic. So if any two vectors are perpendicular, the dot product is 0. So NP dot ON becomes 0. NP can be written as OP minus ON. Any vector can be written in terms of position vector, then substitute and get the answer. And two forms, one is vector form, the other one is Cartesian form. Now equation of plane passing through a point and perpendicular to a given vector. Now we'll derive another equation that is also equation of plane. It is passing through one point and perpendicular to the given vector. So here, so I'll take 3 dimensions as usual, x-axis, y-axis and z-axis and origin, and I need to derive a plane. This is the required plane, say, and it is passing through a known point. Known point is what? A, and it is perpendicular to a vector, and the perpendicular vector I call it as vector n. Vector n is the perpendicular vector to the plane P1, and the planes, there may be several planes perpendicular to this, but this plane is passing through one point. For any derivation, we have to assume or construct the following. What is the first construction? The very first construction is consider a P, point P, let P be a point in the plane, and join AP, and always draw position vectors. So what is position vector of A? OA. OA means from origin to A, you draw one vector OA, always we call it as vector A. And what is OP? Draw a position vector from O to P. What is OP? OP is always R. I told you. So in the diagram, position vector of the point A is small a, position vector of point P is small r. That's it. So now we have considered, so write considerations. What are the considerations? Consider a plane. We have taken a plane, consider a plane, passing through, the plane is passing through point. What is the point it is passing through? A is equal to, say, x1, y1, z1, and perpendicular to, and it is perpendicular to vector n. And as usual, we will take one P be a point. Let P be a point in the plane. P be a point in the plane with position vector. What is its position vector? With PV, position vector. OP is always what? R. These are the considerations. So from this diagram, it is very clear that if I produce this n is also perpendicular to AP. N and AP, how these two are? So n is like this, AP is like this. This is n and this is AP. How these two are? N and AP are again, so A to P, sorry. N and AP, they are again perpendicular. If any two vectors are perpendicular, then the dot product is 0. This is A to P, and these two are perpendicular to each other. If I produce, they are perpendicular. If any two vectors are perpendicular, the dot product is 0. So from the figure, you can see the figure, N and AP. This is your AP and this is N, they are perpendicular. Vector AP and vector N are perpendicular. If any two vectors are perpendicular, then their dot product is 0. So therefore I can take, vector AP dot vector N is equal to 0. And AP can be written as OP minus OA. You know, any vector can be written in terms of position vector. So AP can be written as OP minus OA dot N equal to what? 0. So now what is OP? In the diagram, OP we assumed as what? OP is vector R minus OA is vector A dot vector N equal to what? 0. See, in the, so we got OP in all the derivations OPs are, we got OA means what? Vector A is what? 0. I am substituting dot N is 0. So vector R minus vector A dot N is equal to 0 is the equation of the plane. What is this? This is the equation of the plane. This is the equation of plane passing through a point whose position vector is vector A and it is perpendicular to the plane called vector N. N is the perpendicular vector. Now we need Cartesian form. So Cartesian form, as usual, if you want Cartesian form, assume the points. Cartesian form. So always if they ask you Cartesian form, you have to first derive vector form. So I'll take the point A. A I took it as what? X1, Y1, Z1, and OA, position vector of A. Position vector of A is vector A, that is x1 I cap plus y1 j cap plus z1 k cap. And I'll take another point P. Always in all the derivations, we'll take P as x, y, z. Then I'll write OP. What is OP? Vector OP is vector R. Vector R is what? xi cap plus yj cap plus zk cap. And as usual, we'll take vector n. Vector n. So now we are deriving Cartesian form. So we'll assume vector n is normal. Normal, I'll take it as ai cap plus bj cap plus ck cap, where a, b, c are the direction ratios of normal. So now by vector form, just now we derived vector form. Vector form, plane is by vector form what we derive? By vector from plane is r minus a dot n equal to 0. So that's what. So r minus a dot n equal to what? 0. So dear students, n is readily available. R minus a, just you find out how to find r minus a. R minus a means subtractant. R is here. This is your r and this is your a. Subtract them. See, x minus x1 I cap, x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. So now substitute in it. So r minus a dot n cap is equal to n equal to 0 means, so r minus a is x minus x1 I, y minus y1 j, z minus z1 z. So these two you should do dot product and substitute in it. So now you know r minus a dot n is your plane. So I'll substitute it. How to do dot product of any two vectors? Multiply the quotients and add. What is the quotient here? A. What is the quotient here? X minus x1. So that is a into x minus x1 plus y quotient, j quotient, b into y minus y1 plus c into z minus z1 equal to what? 0. So finally, what is the plane equation? A into x minus x1 plus b into y minus y1 plus c into z minus z1. This is the Cartesian equation of plane. What is the Cartesian equation of plane? A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0 is the Cartesian equation of plane. So now we derive two forms. So let me summarize. So first I give normal form of plane. For normal form, again we have two forms. So normal form, we have two forms. One is vector form, the other one is Cartesian form. What is the vector form? Vector r dot n cap is equal to 0 and d. And what is this? This is lx plus my plus nz equal to d. Further, Cartesian form, equation of plane through a point and perpendicular to vector. For this, again two forms. Just now we derive one vector form, one Cartesian form. So vector form is what? R minus a dot n is equal to 0. And Cartesian form, a into x minus x1 plus b into y minus y1 equal to plus c into z minus z1 equal to 0. So dear students, we have two forms. We have learned two forms, but still we have three more forms. So first form we derived Cartesian form, normal form. First form is normal form. For this we derived Cartesian form also. So both. I've written the summary. So both the forms you should remember. So now today I started with plane. In plane I give two forms. One is normal form, the other one is equation of plane passing through a point and perpendicular to a given vector. For both the forms I give vector form and Cartesian form. Please sit and revise this. The derivations are important for PU board exams. Sit and practice them. I'll see you in my next session. Thanks for attending. Thank you.